Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the volume of a cylinder practice questions. If you need any extra help on finding the volume of a cylinder, if you go to corbettmaths.com/contents and scroll down to video 357, there's a video tutorial there on finding the volume of a cylinder. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. So question number one. Question number one, we've been given this cylinder and we've been told the cylinder has got a radius of 2 centimeters and a height of 5 centimeters. And we've been asked to work out the volume of the cylinder. So to find the volume of a cylinder, we do the volume is equal to pi r squared h. In other words, find the area of the circle and then multiply by how tall the cylinder is. So we're going to do pi times 2 squared and then times that by 5. So let's do that. So we're going to do pi times 2 squared to get the area of the circle and then multiply by 5, the height. So times by 5. And when we do, and this is a calculator question, pi times 2 squared times 5, that's equal to 20 pi, so 20 pi. Alternatively, we could write it as 62.83185 and so on, centimeters cubed, because it's the volume and we're dealing with centimeters, so it's going to be centimeters cubed. So the answer will be 62.83 to 2 decimal places, or 20 pi. So let's do that, 62.83. And that's our answer to 2 decimal places. Okay, let's have a look at our next question, question number 2. So question number 2 says, shown below is a cylinder. So we've got the cylinder and we've been asked to calculate the volume of the cylinder and to give our answer to 1 decimal place. And as we can see, it's a calculator question. So the volume is equal to pi r squared h, the area of the circle times by the height. So if we have a look at this circle, the diameter of the circle, the whole way across is 12 centimeters. So that means the radius of the circle, so from the distance from the center to the edge, will be 6 centimeters. That's the radius of the circle. So if we do pi times 6 squared, that will give us the area of the circle. And then we just need to multiply by the height, which is 6 also. So the volume is equal to pi times 6 squared, that's the area of the circle, times by the height of the cylinder, which is 6. And then that will give us our answer. And when we do that, we get an answer of 216 pi, but the question did say to 1 decimal place, so as a decimal number, that's equal to 678.584 and so on, centimeters cubed. And we've been asked to give our answer to 1 decimal place, so because it's 678.58, we're going to round up, so it's going to be 678.6 centimeters cubed, and that's our answer. Okay, let's have a look at our next question, question number 3. So question number 3 says a can of baked beans is shown below. So we've got this can of baked beans and it's got a radius of 3.5 centimeters. So the radius of the cylinder is 3.5 centimeters and the height of the cylinder is 11 centimeters. And we've been asked to calculate the volume of the can. So we just need to find the volume of the cylinder. So the volume is equal to pi r squared h. So it's going to be pi times the radius, which is 3.5, so 3.5 squared, times by the height of the cylinder, which is 11. And whenever we do pi times 3.5 squared times 11 on our calculator, we get, that's equal to 423.3296101, so on, centimeters cubed. Now I'm going to round this answer, I'm going to round it to 2 decimal places, so my answer to 2 decimal places would be 423.3, and we've got 2 9, so let's round up 0.33 centimeters cubed to 2 decimal places, and that's it. So that's the volume of the can. Okay, let's have a look at question number 4. So question number 4 says, below is a cylinder. So we've got the cylinder and it's got a diameter of 8 centimeters and a height of 10 centimeters. And we've been asked to find the volume of the cylinder and to give our answer in terms of pi. So this is a non-calculator question, so we're not using a calculator in this question. So what we're going to do is we're going to find the area of the circle and then times it by 10, the height of the cylinder. So let's find the area of the circle to begin with. So that's going to be pi r squared, so pi times. Now the radius of the circle will be from the center to the edge, that would be 4 centimeters. If the whole way across is 8, half of that is 4. So we're going to do pi times 4 squared. 4 squared is equal to 16, so that's pi times 16. So the area of the circle is 16 pi centimeters squared. So we've got the area of the circle. Now we just need to multiply by the height of the cylinder to find the volume of the cylinder. So the volume of the cylinder will be equal to the area of the circle, 16 pi, times by the height of the cylinder, 10. So we need to do 16 pi times 10. So whenever we do 16 pi times 10, we can do 16 times 10, that's going to be 160 pi. So the answer would be 160 pi centimeters cubed. So the answer is 160 pi. And that's it. That's our answer in terms of pi. Okay, let's have a look at our next question, question number 5. So question number 5 says, shown below is a cylinder with a diameter of 5 centimeters and a height of 17 centimeters. And we've been asked to calculate the volume of the cylinder and to give our answer to 1 decimal place. So the volume of the cylinder is equal to pi r squared h. So pi times the radius squared times the height, the area of the circle times the height. And that will give us the volume of the cylinder. So we need to find out what the radius of the circle is and what the height of the cylinder is. So the radius of the circle. The diameter of the whole circle is equal to 5 centimeters. That means the radius halfway across, so from one side to the other side, would be 2.5 centimeters. So we've got our radius and we've got the height of the cylinder. So let's substitute those into our formula. So it's going to be pi times the radius squared, so it's going to be 2.5 squared, times by the height of the cylinder, which is 17. And then we can just get our calculator and do pi times 2.5 squared times 17, and that's our answer. Pi times 2.5 squared times 17 is equal to 333.794 and so on centimeters cubed. Now we've been asked to give our answer to one decimal place, so it's going to be 333 point, then we've got 79, so it's going to be 0.8 centimeters cubed. And that's it, that's our answer. Okay, let's have a look at question number 6. So question number 6 is a non-calculator question, and we've been asked to calculate the volume of the cylinder and to give our answer in terms of pi, and to state the units of our answer. So we've got this cylinder, it has got a radius of 3 centimeters, so from the center to the edge is 3 centimeters, and the height of the cylinder is 2.5 centimeters. So let's find the area of the circle to begin with. So it's going to be pi times the radius squared, so it's going to be pi times 3 squared, and 3 squared is 9, so it's going to be 9 pi. So that's the area of the circle, 9 pi centimeters squared. Now to find the volume of the cylinder, we're going to do the volume is equal to 9 pi multiplied by the height or the length of the cylinder. So the height of the cylinder is 2.5. So if we do 9 pi times 2.5, that will be the volume of the cylinder. So let's do 9 times 2.5 to begin with to see what that is, and then that'll be how many lots of pi we'll have. So we need to do 9 times 2.5, so that's 2.5 multiplied by 9. And this is non-calculator question, so I'm just lining them up. 9 times 5 is 45, put our 5 down, carry our 4. 9 times 2 is equal to 18, plus 4 is 22. So that'll be equal to 22.5. So our answer will be 22.5 pi. And now we need to include our units, because it says state the units of your answer. So we're dealing with centimeters, so it's going to be centimeters cubed. So the volume of the cylinder would be 22.5 pi centimeters cubed. Okay, question number 7. So question number 7 says, Carl is filling flower pots with soil. So he's putting soil into flower pots. So this is a flower pot. Each flower pot is a cylinder with a radius of 7 centimeters and a height of 20 centimeters. Carl has 50 litres of soil. How many flower pots can be filled? So we need to find out how many of these cylinders can be filled using this 50 litres of soil. And just before we begin, I'm going to change this 50 litres into centimetres cubed, because we're dealing with centimetres here, so it'd be handy if we could change this 50 litres into centimetres cubed. So 1 litre is equal to 1,000 centimetres cubed. So 1 litre is 1,000 centimetres cubed. So if we had 50 litres, that would be 50 times greater than 1,000, or 50 times 1,000, which would be 50,000. So 50,000 centimetres cubed. So he's got 50,000 centimetres cubed of soil. Now we want to find out how many of these flower pots can be filled using this 50 litres or 50,000 centimetres cubed of soil. So what we should do is find the volume of the cylinder and then just see how many of them can be filled by dividing the total amount of soil by the volume of the flower pot. So let's find the volume of this flower pot to begin with. So the volume, and it's a calculator question, so volume is equal to pi times the radius squared times the height. So the area of the circle times the height. So we're going to do pi times the radius of the circle is 7, so 7 squared multiplied by the height of the cylinder, which is 20. So if we do pi times 7 squared times 20, that will give us the volume of one of our flower pots, and that's equal to 3,078.760801 and so on centimetres cubed. So that means that each flower pot holds 3,078.76 and so on centimetres cubed of soil. So Carl's going to fill up as many of these as he can using his 50,000 centimetres cubed. So if we divide his 50,000 by how much soil can fit into one flower pot, we can then see how many he can fill. So let's do 50,000 divided by 3,078.760801 and so on. And I try not to round if I can avoid it, because if I round it, it might affect the accuracy of my answer. So what I'm going to do is on my calculator, I'm going to press 50,000, type in 50,000 divided by, and then I'm going to press answer, and that uses my answer that I got previously, this 3,078.76 and so on. And that will give me an answer of, that's equal to 16.240300 and so on. So that's how many pots he can fill. He can fill 16.24 and so on pots. Now, how many can be filled? Well, he can fill 16 of them. He can't actually fill the 17th one because he's actually only got 16.24 and so on. So he can fill 16 flower pots. That's how many flower pots can be filled, and he's got a little bit left over. And that's it. So the answer is 16. Okay, let's have a look at our next question. Question number 8. So question number 8 says a cylinder has got a radius of 2 centimeters. So the radius of the cylinder is 2 centimeters. And we're trying to find the height of the cylinder, h, and we're told the volume of the cylinder is 100 centimeters cubed. And we want to find h, the height of the cylinder. So what we want to do is we want to find the height of the cylinder. So the volume of the cylinder, this 100, is found by getting the area of the circle and timesing it by the height. So if we can get the area of the circle, if we divide the volume by the area of the circle, that will tell us the height of the cylinder. So let's find the area of the circle to begin with. So that's going to be pi r squared. So pi times the radius, which is 2 squared. That will be the area of the circle. So we're going to do 2 squared, which is 4, and times it by pi. So 4 times pi is equal to 4 pi. So we could leave it as 4 pi here, or 12.56637, and so on. Okay, so that's the area of the circle. Now normally we would then times that by the height to get the volume of 100. So if we divide the volume, the 100, by the area of the circle, 12.566 and so on, that would tell us the height of the cylinder. So I'm going to press 100, or type in 100, divided by answer, and my answer would be 7.957747 and so on centimeters. And if we round this to 2 decimal places, it would be 7.96 centimeters. So the height of the cylinder is 7.96 centimeters. And that's it. So we found the area of the circle. We know if we times the area of the circle by the height, we get the volume. So if we divide the volume by the area of the circle, that will tell us the height. So another approach to this question is to just substitute the values into the formula and to solve the equation. So the volume of the cylinder is equal to pi r squared h. So in other words, pi times the radius squared times the height would be equal to the volume. Now we know what the volume is. The volume is equal to 100. So instead of writing v, I'm going to write 100. And then we've got pi, and then times by the radius squared, so it's going to be 2 squared, because the radius is 2, times by the height. Now we don't know the height, so let's just call that h. So now let's work this out. So we've got 2 squared. Remember, BODMAS, we need to work out our squared first of all. 2 squared is equal to 4. So we've got 100 is equal to pi times 4 times h. Now we want to solve this equation, so we want to get the h on its own. We want like h equals a number. So what we want to do is we want to get rid of this times by 4 and get rid of this pi as well. So let's get rid of the times by 4 to begin with. So let's divide both sides of the equation by 4. And if we divide the left-hand side of the equation by 4, 100 divided by 4 is equal to 25. And on the right-hand side of the equation, we divide it by 4 to get rid of this times by 4. So we'll just be left with pi times h. Now we don't want to times h by pi, we just want h on its own. So let's divide both sides of this equation by pi. So we're going to divide by pi and divide by pi. The right-hand side is quite easy. Pi times h, we divide by pi. Well, we divided by pi to get rid of the times by pi, so we're just left with h. The right-hand side of the equation, we need to do 25 divided by pi. So 25 divided by pi is equal to 7.957747 and so on centimeters. And that's what we've got before. And if we round this to 2 decimal places, that'll be 7.96 centimeters. So that's it. So in this question, you could use either approach. You could use this approach where we write down the formula, substitute the values that we know into it, and solve the equation to then find what the value for h would be. Alternatively, we could work backwards, knowing that if we times the area of the circle by the height, we get the volume. So if we divide the volume by the area of the circle, that will tell you the height. Okay, question number 9. Okay, let's have a look at question number 9. So question number 9 says the cylinder below has got a diameter of 6 centimeters. So the diameter of the cylinder is 6 centimeters. As you can see, the cylinder's on its side. And the volume of the cylinder is 180 pi centimeters cubed. Now, it's a non-calculator question, so I'm just putting down my calculator. And the question says, work out the length of the cylinder. So we need to work out the length of the cylinder. Now, it's laying down, so that's the length this way. So to find the length of the cylinder, remember to find the volume of the cylinder, which is 180 pi. We get the area of the circle, and we multiply it by the length. So if we find the area of the circle, we can then figure out the length by dividing the volume by the area of the circle. So let's find the area of this circle. The radius of the circle would be 3 centimeters because from the center to the edge is half of the diameter. So it's going to be pi times 3 squared. 3 squared is equal to 9, so it's going to be 9 times pi, or 9 pi. So that means that the area of the circle is 9 pi centimeters squared. Now to get the volume, this 180 pi, we would have times that 9 pi by how long the cylinder is. So that means if we divide 180 pi by the area of the circle, 9 pi, we can find the length. So we need to do 180 pi divided by 9 pi. So 180 pi divided by 9 pi, well, what do we times 9 pi by to get 180 pi? Well, that would be 20. So that means the answer would be 20, or 20 centimetres. So that means the length of the cylinder is 20 centimetres. And just to recap that, to find the area of the circle, we do pi times 3 squared. 3 squared is 9, so that's 9 pi. And 9 pi times 20 would give us 180 pi. So that means the length of the cylinder must be 20 centimetres. So that's one approach. Another approach is we could use the formula. So the formula is the volume is equal to pi times the radius squared times by the height. So that's going to be equal to the volume, which is 180 pi, is equal to pi times the radius of the circle. So it's going to be 3, halfway across the circle is 3 centimetres, so times by 3 squared, times by the height. In this case, because it's laying down, it's going to be the length. So let's call the length L, because we're trying to find the length of the cylinder. So let's do to multiply by L. So now we've got an equation. We've got our numbers and L. So let's find out what L is, the length of the cylinder. Now, remember our Bob maths, we need to work out the squared first of all. 3 squared is 9. So we've got 180 pi equals pi times 9 times L. Now we want to get L on its own, so we want to solve this equation. So I'm going to divide by 9 first of all. So divide by 9 and divide by 9 to get rid of the times by 9. 180 pi divided by 9, well, 180 divided by 9 is 20, so it's going to be 20 pi is equal to pi times L. Now we want the L on its own, so we don't want this multiplied by pi here, so we're going to divide both sides of our equation by pi. So divide by pi and divide by pi. 20 pi divided by pi would be 20, and on the right hand side of our equation, we divided by pi to get rid of the times by pi, so we're just going to be left with L. So L equals 20. So L is 20 centimetres, and that's it. Okay, our next question, question number 10. So question number 10 says, a cylinder has got a height of 15 centimetres and a volume of 500 centimetres cubed. Calculate the radius of the cylinder. So in this question, we've got two approaches again. I'm going to do both of them. Our first approach is we want to find the radius of the cylinder. So I'm just going to sketch a cylinder here. Now, this isn't going to be perfect. It's just a little sketch. So here is my cylinder. So that's my sketch of a cylinder. It's not the greatest, but it'll do. And we're told that the cylinder has got a height of 15 centimetres. So it's got a height of 15 centimetres. The volume's equal to 500 centimetres cubed. And we're trying to find the radius of the cylinder. So the radius, let's call that x, the radius of the cylinder. So to find the radius of the cylinder, well, we know the volume and we know the height. So if we divide the volume by the height, we get the area of the circle. So let's do 500 divided by 15 to begin with. So 500 divided by 15 will be the area of the circle. 500 divided by 15 is equal to 33.333 and so on centimetres squared. So that's going to be the area of the circle. So now we know the area of the circle, we can work backwards to find what the radius of the circle would be. So remember, to find the area of the circle, we use the formula pi r squared, we square the radius and then times by pi. So if we take the answer, our 33.333 and so on, and we work backwards, we divide by pi and then square root, we will find the radius of the circle. So let's take our 33.333 and so on and divide by pi. So that would be equal to 10.610329 and so on. And now that's equal to the radius squared, so we now need to square root that to find the radius. So the square root of 10.6103 and so on. Now I'm just going to use my calculator display, so I'm just going to press the square root of answer and press equals, and that's equal to 3.25735 and so on centimetres. Now the question doesn't ask us to round it to so many decimal places. I'm going to round it to 2 decimal places, so it's going to be 3.26. So 3.26. So the radius of the circle will be 3.26. And just checking how we did that, the volume was equal to 500 centimetres cubed. We divided it by the height of the cylinder, the 15, to find the area of the circle. To find the area of the circle, we square the radius and then times it by pi. So if we divide by pi and then square root it, we can find the radius of the circle, which is also the radius of the cylinder. So that's one approach. Alternatively, we could use the formula. So let's have a look at that approach now. So in this question, we've been asked to calculate the radius of the cylinder. So the volume of the cylinder is equal to pi times the radius squared times the height. We know the volume is equal to 500, so 500 is equal to pi times the radius. And we don't know the radius, so let's just leave it as the radius squared times by the height of the cylinder, which is 15. Now we've got an equation. Now this is just an equation because we've got numbers and r, so we want to solve this to find what r is. Now with this equation, we want to get the r on its own, so let's get rid of the times by 15 first of all. So let's divide both sides of the equation by 15. So on our right hand side of the equation, we're dividing by 15 to get rid of the times by 15, so we're just going to be left with pi times r squared. And on the right hand side of the equation, we've got 500 divided by 15 is equal to 33.33 and so on. Now we want to find what our radius is, so we want to get rid of this times by pi. So let's divide by pi and divide by pi. So 33.333 and so on divided by pi is equal to 10.6103 and so on. And on the right hand side of the equation we had times by pi, we divided by pi to get rid of the times by pi, so we're just left with r squared. So that's the radius squared. We don't want the radius squared now, it's the radius, so it's going to be a positive number, so we can just square root this. And if we square root 10.6103 and so on, we will get the radius of the circle. So if we do the square root of that, that's equal to 3.257 and so on centimeters. And let's round our answer again to 2 decimal places, that'll be 3.26. And that's it. Okay, question number 11. Okay, question number 11. So question number 11 says, shown below is a cylindrical water tank and the height of the water tank is 4 meters. So the height of this water tank is 4 meters. And we're told the volume of the water tank, that's 6.4 meters cubed or cubic meters. And we're asked to find the diameter of the water tank. So in this question, we can use 2 different approaches. We can work backwards and find the diameter of this water tank. Alternatively, we could use the formula and that would help us as well. So I'm going to do both. So first of all, working backwards. So we've got the volume and we know the height of the cylinder. So if we divide the volume by the height, we will find the area of the circle. So let's do 6.4 divided by 4. And it's a calculator question, so that's quite nice. 6.4 divided by 4 is equal to 1.6, so 1.6 meters squared or square meters. That's the area of the circle. If we divide the volume by the height, we get the area of the circle, the area of the cross section. So we now know the area of the circle. Remember, the area of the circle is pi r squared. So to find the area of the circle, we square the radius and times it by pi. So if we take this and divide it by pi and square root it, that will give us the radius of the circle. And then at the end, we can just double it to find the diameter. So let's find the radius of the circle to begin with. Let's find r, the radius of this circle. So let's find r. So let's start with our 1.6 and let's divide it by pi. And if we do 1.6 divided by pi, that's equal to 0.50929 and so on. So that's going to be our radius squared, because remember, to find the area of the circle, we square and then times by pi. So if we divide by pi, that's now going to be r squared. We now need to square root that. So we're going to do the square root of 0.50929 and so on. So let's find the square root of that and see what we get. And that's equal to 0.713649 and so on. So that is the radius of our cylinder. The distance from the centre to the edge of the cylinder is 0.7136 and so on meters. Now that's the radius. We've been asked to find the diameter of this water tank. So if we times this by 2, that will tell us the diameter, x. So let's do 0.71364 and so on, and do multiply by 2 and see what we get. So times 2 is equal to 1.427299 and so on. And let's round this. Let's round it to 3 decimal places. So that would be 1.42. We've got 7 2, so that's going to be 7 meters. So that means that the diameter of this water tank is 1.427 meters. And that's it. So that's one approach. Alternatively, we can use the formula. Let's do that as well. So here we've got a cylinder and we want to find its diameter. So let's start off with the formula, which is the volume is equal to pi times the radius squared times by the height. So we're going to find the radius and then double it to find the diameter. So the volume is equal to 6.4. So we've got 6.4 is equal to pi times by the radius squared. Well, we don't know the radius, so the radius squared times by the height. And the height of the cylinder is times by 4. So here we've got an equation, we've got numbers and we've got r. So let's find what r is. So we want to get the r on its own. So we want to get rid of the times by 4, we want to get rid of the times by pi, and we want to get rid of this squared. So let's get rid of the times by 4 to begin with. So let's divide by 4 and divide by 4. So 6.4 divided by 4, so 6.4 divided by 4 is equal to 1.6. So the left hand side of our equation would be 1.6 equals, and on the right hand side of our equation we divided by 4 to get rid of the times by 4, so we're left with pi times the radius squared. Now whenever we're solving equations we work in reverse BODMAS order, so we want to get rid of any adds and subtracts, then any divisions and multiplications, and then any squares and square roots and so on. So we've got our times by pi and our squaring, so we're going to get rid of our times by pi first of all. So let's divide by pi and divide by pi. So on our left hand side we've got 1.6 divided by pi, and that is equal to 0.50929 and so on. And on the right hand side of our equation we divided by pi to get rid of the times by pi, so we're just left with the radius squared, or r squared. So we've got r squared, we don't want squared, we just want the r. Now r is the radius of a circle, so we can just square root here. So the square root of 0.50929 and so on will give us the radius of our circle. And whenever we square root that, we get an answer of 0.713649 and so on. So that is the radius of our circle. We've been asked to find the diameter of the water tank, so that's going to be double this. So we're going to take our 0.713649 and so on, leaving it on the calculator display, multiplied by 2 is equal to, so times by 2 equals 1.427299 and so on. Let's round this to 3 decimal places, that'll be 1.42. We've then got 72, so it's just going to be 7 meters, and that's the diameter of the water tank, 1.427 meters to 3 decimal places. Okay, let's have a look at our next question, question number 12. So question number 12, we're being shown this paddling pool, and it's got a radius of 1.3 meters and a depth of 40 centimeters. Now be careful here because we've got meters and centimeters, so we may need to convert those. Felix is filling the paddling pool at a rate of 15 liters a minute. So 15 liters, well, 1 liter is equal to 1,000 centimeters cubed. So 15 liters will be equal to 15,000 centimeters cubed. So that's the rate he's filling it, 15,000 centimeters cubed of water every single minute. And we've been asked to work out how long it would take him to fill the paddling pool. Give your answer to the nearest minute. So really we need to find the volume of the paddling pool, how much space is inside of it. So let's find the volume. Now because we know the 15 litres is 15,000 centimeters cubed, I'm going to deal with centimeters in this question. So I'm going to change my 1.3 meters into 130 centimeters. So let's find the volume of this paddling pool in centimeters cubed. So the volume is equal to pi r squared h, so it's going to be pi times the radius, 130 squared, times by the height, which is 40. And when we work that out, we get the volume of the pool. So pi times 130 squared times by 40 equals 2,123,716.634 centimeters cubed. So that's the volume of this paddling pool. Now it's being filled at the rate of 15,000 centimeters cubed every single minute. So if we divide the volume by this 15,000, that will tell us how many minutes it'll take to fill this pool. So let's take the total volume, the 2,123,716.634, and divide it by 15,000 and see how many minutes it should take. Now I've still got this on my calculator display, so I can just press divide by 15,000 equals, and that gives me an answer of 141.58111089 and so on minutes. Now we've been asked to give our answers to the nearest minute, so to the nearest minute that would be 142 minutes. So it'll take over 2 hours to fill this paddling pool at the rate of 15 litres a minute. Okay, let's have a look at our next question. Okay, let's have a look at question number 13. So question number 13 says, here's the front elevation of a cylinder on a centimetre square grid. So we've got a cylinder and this is its front elevation. So this is it as we're looking straight at it. So it's laying down, because if we can look at it and it's a circle, the cylinder must be laying down. Imagine if we had a Pringle can and we were looking at it directly and it was a circle, the picture of that front elevation was a circle, that means that it would be laying down. Maybe a giant Pringle can that we're looking at. Okay, but if the front elevation is a circle, the cylinder must be laying down. And we're told the volume of the cylinder is 12 pi centimeters cubed. So we've got the volume of the cylinder, and we're asked to draw the side elevation of the cylinder. So if that's the front of the cylinder here, if we look at the cylinder from the side, so if we go from the front and go stand around the side and we look at the cylinder from the side now, what we're going to find is that that side elevation is a rectangle. The height of it will be the same as this. So if we look at the front elevation, the height of this front elevation, the distance from here to here, will be 1, 2, 3, 4 centimeters. So whenever we draw a rectangle, it will have a height going from the surface of the ground up to its highest point in that rectangle of 4 centimeters. But in terms of its length, we're going to have to work that out. We don't know how long that rectangle is. In other words, the depth of this cylinder. So in other words, how long is that cylinder we're looking at? So we're told the volume of the cylinder is 12 pi centimeters cubed. So let's find the area of this circle and see what we get. So this circle has got a radius of 2 centimeters. So remember, to find the volume of a cylinder, we get the area of the circle and times it by how long it is. So if we can work out the area of the circle, so using pi r squared, so pi times 2 squared. 2 squared is 4, so that's going to be 4 pi. So that's the area of the circle, 4 pi centimeters squared. Now we know the volume is 12 pi centimeters cubed. So if we divide the volume by the area of the circle, that'll tell us how long the cylinder is. So if we do 12 pi divided by 4 pi, that would be the length of the cylinder. So 12 pi divided by 4 pi, well, what do we times 4 pi by to get 12 pi? That would be 3. So that means this cylinder is 3 centimeters deep. So if we look at this cylinder from the front, well, we can just see the circle. But if we walk around to the side, we'll see this rectangle that's got a height going from the bottom up top of 4 centimeters, but the depth, how long it is 3 centimeters. So let's draw that. So let's go down to our grid and draw that. So we want to draw a rectangle that is 4 centimeters tall. So from the bottom to the top is 4 centimeters because it's got the same height as the front elevation. But in terms of the depth of this, so that's the front of it. So if we're looking from this side here now, that's the front. And in terms of the depth of our rectangle, it would be 3 centimeters. So 1, 2, 3. So that means that our rectangle is 4 centimeters tall and 3 centimeters wide, and that's it. So if we have a look at our front elevation again, we have got a circle. It has got a radius of 2 centimeters. 2 squared is 4, so that's going to be 4 pi centimeters squared for the area of the circle. If we times that by how deep the cylinder is, which is 3 centimeters, we get our 12 pi, which is our volume, 12 pi centimeters cubed. So this cylinder has got a diameter of 4 centimeters and it's got a depth of 3 centimeters. So if we now look at the cylinder from the side, we will see a rectangle. The height of that rectangle will be 4 centimeters and the width of it, how far it goes back, is 3 centimeters. And that's what we've drawn. And that's it. Okay, let's have a look at our next question. Question number 14. So question number 14, we've been given a cylinder and it's got a diameter of 12 centimeters and a height of 14 centimeters. And we've got this cube that's got a side length of y. And we're told that the cylinder and the cube have got the same volume and we've been asked to find y. So if we find the volume of the cylinder, that will be the same as the volume of the cube because we're told that. So let's find the volume of the cylinder. So the volume of the cylinder will be volume equals pi times the radius squared times by the height. So it's going to be pi times the radius, which is halfway across, which would be 6 centimeters, so 6 squared, times by the height of the cylinder, which is 14. So if we do pi times 6 squared times by 14, that'll be the volume of the cylinder. So let's do that and see what we get. So that will be equal to 504 pi, or equal to 1,583.362697 and so on centimeters cubed. So that's the volume of the cylinder. Now we're told in the question the volume of the cylinder and the cube are the same. So that means the volume of this cube is either 504 pi or 1,583.36 and so on centimeters cubed. So we've now found the volume of this cube. The volume of the cube is 1,583.36 and so on centimeters cubed. Now remember, if we cube, the length, the width and the height are all the same. They're all equal to y centimeters. So that means we do y times y times y, and that gives us the volume. So whenever you multiply a number by itself and by itself again, that's cubing it. So if we want to find out what the number is, we want to do the inverse, which is the cube root. The inverse of cubing is cube rooting. So if we work out the cube root of 1,583.36 and so on, or just 504 pi, we can then work out what the side length is. So I'm going to press the cube root of, and I'm just going to press answer because this is already on my calculator display. That's equal to 11.655 and so on centimeters. So that means the side length of this cube is 11.65538 and so on centimeters. And let's give our answer to 3 decimal places. So the 3 decimal places will be 11.655. 11.655 centimeters to 3 decimal places, to 3 dp decimal places. And that's it. And that's it. So just to recap, we find the volume of the cylinder by using pi r squared times the height, and that gave us the volume. Once we knew the volume of the cylinder, that's the same as the volume of the cube. And with the cube, we know that the length times the width times the height will be equal to the volume. So if we do the cube root, we can find out that side length. So we've done the cube root of 1,583 point so on, and that gave us 11.655 and so on. And we rounded that to 3 decimal places to 11.655. And that's it. Okay, question number 15. Okay, let's have a look at question number 15. So question number 15 says, shown above is a prism that is 1 meter long. So we've got this cross section, which is a rectangle and a semicircle, and it's 1 meter long. And the cross section of the prism is a semicircle above a rectangle. Calculate the volume of the prism. Give your answer correct to 1 decimal place. So to find the volume, we're going to need to find the area of the cross section, so the area of this region, and we need to multiply it by how long it is, how deep the shape is. So let's find the area of the cross section to begin with. So as we know, it's a rectangle and a semicircle. So let's find the area of the rectangle to begin with. So that's going to be the length times the width. So that's going to be 50 times 30 is equal to 1,500 centimeters squared. So that means the area of this rectangle would be 1,500 centimeters squared. So that's the area of that part. So we just now need to find the area of the semicircle and add them together, and that will be the area of the cross section. So in terms of the semicircle, the area of a semicircle is half the area of the whole circle. So let's consider this whole circle. I'm just going to change colour of pen to blue here, and let's imagine we've got a whole circle. So we've got this whole circle here, and we know that the diameter of the whole circle would be 50 centimetres. So that means that the radius of that would be 25 centimetres, the distance from the centre to the edge. So if we do pi times 25 squared, it will give us the area of this whole circle. And then we'll just half it to get the area of the semicircle. So let's do that. So let's do pi times 25 squared. So pi times 25 squared, and this is a calculator question, so pi times 25 squared is equal to 625 pi, so 625 pi, or alternatively we could write it as 1963.495 and so on. So that's the area of the whole circle. Now we just want to find the area of the semicircle, so let's half this. So let's do 1963.495 and so on divided by 2. And when we divide by 2, that's equal to 981.7477 and so on centimetres squared. So that's the area of the semicircle, 981.7477 and so on. So we've now got the area of the rectangle and the area of the semicircle. So if we add them together, that'll be the area of the cross section. So let's do that and see what we get. So that's going to be 981.7477042 and so on, plus 1,500, and that's equal to 2,481.747704 and so on. So that's the area of the cross section. Now we just need to multiply by how long the prism is, and that's equal to 1 meter. Now we're dealing with centimeters, so let's change that into 100 centimeters. So we just need to multiply this by 100. So 2,481.7477 and so on times by 100 is equal to 248,174.77. And we've been asked to give our answer to one decimal place, so our answer would be 248,174.8 centimetres cubed. And that's it. Okay, let's have a look at our next question. Okay, question number 16. Now, I really like this question. We've got a cuboid is full of liquid. So we've got this box or something like that, and it's full of liquid. It measures 5 centimetres by 9 centimetres by 6 centimetres. And we've got the cylinder, and this cylinder is empty at the minute. And some of the liquid is poured from the cuboid into the cylinder, until the point where the height of the liquid is the same in both containers. So in other words, the height of the water in the cylinder is the same as the height of the water in the cuboid. So if you put them side by side, the level of the water would have the same height. And we've been asked to work out h. What height would that be? So we're told the cuboid is full of liquid. And so now in this question, I might say water or liquid. I mean the same thing, okay? So if I do say water, just pretend I'm saying liquid. So we have got this cuboid, and we know it's full of liquid. So this is all the liquid to begin with, okay? So this is empty. So if we find the volume of this cuboid, that would tell us how much liquid we've got all together. So if we do 5 times 9 times 6, that's equal to 5 times 9. It's a calculator question. 5 times 9 times 6 is equal to 270 centimetres cubed. So that's how much liquid we have in total, 270 cubic centimetres or centimetres cubed. And then what we're told is some of this liquid, some of this 270 centimetres cubed, is poured into the cylinder until they get to the same height. So it's not that half and half are kept in each container, because then they wouldn't have the same heights necessarily. But what we're told is that some of this liquid is poured into here until they get the same height. So let's sketch what that might look like. Some of this water's been poured out, so it would have a new height. So it would be, some of it's left, so then you would have this liquid left inside of here, and this bit would now be empty. And then in the cylinder, there would be the same height of liquid as well. So there'd be liquid down here, and it'd be the same height as the liquid in this cuboid. And we've been asked to find out this value of height. So in other words, how deep is this liquid? And in this question, we've been asked to work out what this value for h is. In other words, how deep is that liquid in the cuboid and the cylinder that have got the same height? So what we know is that the volume of liquid in here plus the volume of liquid in here would have to be equal to 270 centimetres cubed. So if we work out the volume of liquid in this cuboid, and we find the volume of liquid in this cylinder and add them together, the answer will be 270. So let's do that. So let's have a look at our cuboid. To get the volume of liquid in this cuboid, we would do the length times the width times the height. Now, the height's not going to be 6 because it's not the whole way up to the top. It's going to be 5 times 9 times h. That will be the volume of liquid in here. We don't know the value for h, so we don't know how much volume's in there yet, but we'll figure that out. So the volume of liquid in here would be, so for the cuboid, it would be 5 times 9 times h. That would be how much liquid, that would be the volume of liquid in this container. 5 times 9 times h. That would give us the volume of that. Now in terms of our cylinder, if we want to find out the volume of liquid in this container, we've got the area of the base is pi r squared, and then we just need to multiply by the height. So we're going to do pi times r squared, the radius, which is 5 squared. That'll be the area of the circle. And then we just need to multiply by how tall the liquid is, how deep is the liquid, so times by h. So that's the volume of liquid in the cuboid, 5 times 9 times h, and this is the volume of liquid in the cylinder, pi times 5 squared times h. But what we do know is that if we have this amount of liquid and this amount of liquid and we put them together, there'd be 270 centimeters cubed. So that gives us an equation we can write. Now, if we do a bit of simplifying here, 5 times 9 is equal to 45h, that's 45h. And if we have if we look at our cylinder, we've got 5 squared is equal to 25. So we've got 25 times pi times h, so it's 25 pi h. So if we add these together, we get 270. So 45h plus 25 pi h is equal to 270. So here we've got an equation. Now it looks a bit tricky, but we've just got so many lots of h plus so many lots of h equals 270. If it was 3h plus 4h, that'll be 7h. That's nice and easy. In this question, because we've got the pi, it looks a bit trickier. In the questions like this, I like to change my 25 pi into a decimal. I just find it helps me sort of figure it out more easily. So we've got 45h, and then we've got plus, and we've got 25 pi. So 25 times pi is equal to 78.5398 and so on. H is equal to 270. So we've got 45 lots of h, 78.539 and so on lots of h is equal to 270. So if we add 45 and 78.5 and so on, that tells how many lots of h there are altogether. So plus 45 is equal to 123.5398 and so on lots of h, and that's equal to 270. So that's an equation we just need to solve. So if we divide both sides of this equation by 123.5398 and so on, we'll get our value for h. So divide by 123.5398 and so on, divide by 123.5398 and so on, and we'll be left with, we're dividing by that, so we're not times about, so we'll just be left with h. And on the right hand side of our equation, 270 divided by answer is equal to 2.1855 and so on centimeters. And let's just round this to 2 decimal places, so that'll be 2.19. So that means the depth of the liquid in these containers will be approximately 2.19 centimeters. So 2.19 centimeters. So if we had a cuboid, this cuboid full of liquid, and we were to pour some of it into the cylinder so that they both had the same height, the height of that liquid would be approximately equal to 2.19 centimeters. And that's it. Okay, let's have a look at question number 17. So question number 17 says the volume of the cuboid and the volume of the cylinder are the same, or equal. And we've been asked to find h in terms of x. So we've got this cuboid, it's got a height of x, a width of x, and a length of x. And we've got the cylinder, which has a radius of x and a height of 3x. And we're told that the volume of the cuboid and the cylinder are equal. Find h in terms of x, and to give our answer in its simplest form. So let's find the volume of this cuboid to begin with. So the volume is equal to the length times the width times the height. So the volume is equal to the length, which would be x, times the width, which would be x, times the height, which would be h. So the volume would be x times x is x squared, times by the height, h, and let's just put those in alphabetical order, so it'll be h x squared. So the volume of this cuboid is h x squared. Now in terms of the cylinder, the formula is the volume is equal to pi times the radius squared times the height. So the volume will be equal to pi times the radius squared, so it's going to be x squared times the height, which would be 3x. Now let's simplify this. We've got x squared times 3x. Well, x squared times x would be x cubed, times 3 would be 3x cubed. So we've got the volume is equal to pi times 3x cubed, and then timesing these together, well, we're timesing 3x cubed times pi, so that would be the volume is equal to 3 pi x cubed. So the volume of the cylinder would be 3 pi x cubed. So we've got the volume of the cuboid and we've got the volume of the cylinder, and we're told they're equal to each other. So that means that hx squared would equal 3 pi x cubed. So we've been asked to find h in terms of x, so we want to simplify this, so we've got h equals something. Now we've got h times x squared, so we don't want this times by x squared. Now x squared will have to be a positive number because we're dealing with the heights and dimensions of cuboids, so we can divide both sides by x squared, so divide by x squared and divide by x squared. H times x squared divided by x squared, we just leave us with our h, so that's great, h. And then on the right hand side we had 3 pi x cubed. We're dividing that by x squared. Well, if you've got x cubed, which is x times x times x, and you're dividing that by x and by x again, you're just going to be left with x. So it'll be 3 pi x, and that's it. So h would be equal to 3 pi x. And that's it. So these have been the video solutions to the volume of a cylinder practice questions. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to the YouTube channel. If you do need any extra help on finding the volume of a cylinder, go to video 357 on Corbettmaths or scan this QR code. But anyway, I hope you found this video useful. Thanks very much. Cheers. Bye.